Hello everyone, this is Prashant, and we are going to go through the unit of perception. And in perception, we are going through perceptual cues. So, what are perceptual cues? Let's start with the definition. Well, perceptual cues are the signals or hints about the location of an object in one's environment. So, how a thing is in my environment, what is its position, what is its location. I use these cues or signals to identify how far away it is from me. So why we do that? Well, basically there is a world. There are concretes in it, and all those concretes are three-dimensional. And yeah, so things appear in the three-dimensional form to us. That's what they are. And we receive information about the location of an object from multiple cues simultaneously. We are combining them, and by a process of abstraction, we are able to distinguish between different cues individually. So I'm gonna go through each cue individually and gonna show you what those cues are. So let's start. So monocular cue, basically you can use these cues from your one eye only, and then there are binocular cue that requires two eyes to identify them, and oculomotor cue, basically they require the movement of eye, maybe your eye lens or your eyeball. And monocular cues are divided in two forms, pictorial or static in nature, and motion, that is some cues that are dynamic in nature, and you can both perceive them through your one eye. So let's start with the monocular cues. Well, occlusion or interposition. Well, when an object is in front of another, it blocks the visibility of another. For example, if there is a child behind the tree, or there is a tiger behind the grass. Well, we know that there is object, and the object that is in front of it is covering it. So that what we know on a perceptual level. The second cue, that is the relative height. So what it is? Well, far away objects appear closer to horizon. Well, there is a sky, and the far away thing, it appears that as if it's closer to the horizon or the sky ahead. So you can see the house behind me, or the trees, or the birds appear closer to the sky in comparison to the ducks, and the tree on the left, on the right side image, appears closer to the horizon than the tree on the right. Well, why? Because it is closer to the horizon. It is far away. That's why it appears closer to the horizon. That's all it is. It is okay. The third cue is linear perspective. Well, what is it? Parallel line appears to meet at a far away distance. Well, it is appear like the whole image or the whole pathway is converging at one point. Well, that is not actually true. The path is parallel, the rail lines are parallel, but they appear as if they are going in a one meeting at one point. Okay. So familiar size. Well, an object appears smaller as it moves away from us. The hand near your eye appears larger. When the hand is pulled back, it appears smaller. Texture gradient. Far away objects appear to condense together. Well, because there are many objects and they are in the limited space, so they appear as if they are close together. When in fact they are almost similar distance to each other. Like these lilies you are seeing. When they are close, they appear far away. When they are far away, they appear to be close together in density. Well, other cue is aerial perspective. Far away objects have fainter shades of a color, like the green fades away in the forest, or the mountains appear to be blue. So that's how it appears to us. So let's just start with the Gibsonian perception. Well, the founder of it was J.J. Gibson, and his theory was that perception is an active process that requires your movement and interaction with the environment. Basically, without movement or interaction with your environment, there will be no perception. So he gave the concept of affordances. So basically, it states that the most information about the things is implicit and directly available to you. So a chair, you can know that the chair is something you can sit on, it's something that is can be thrown, stuff like that, because it is implicit in the object itself. Or maybe first there is a space in a building that is higher than you, like some kind of hole, you can go through it, so you can just perceive it basically. So let's start. So what are the motion cues? Well, there are induced motion, that is stationary or moving object appears to move differently because of the motion of other nearby objects. Basically, if the object is stationary or moving and other objects are moving as well, then relative to both of them, a certain motion is observed. For example, the moon in the sky. If the clouds are moving, the moon appears to be sinking in them. Well, I'm gonna show you how. So let's start. Let's start with a clip. So the clouds are moving forward, that is above me, and the moon appears to be going down. Yep. But the moon is stationary basically. So this is induced motion. So let's start with the next motion cue, that is motion parallax. Well, motion parallax is also a form of induced motion of a moving object, but the nearby objects appear to be moving fast in the opposite direction. The far away objects appear to be moving slow but in the same direction from your fixation point. Everything below the fixation point appears to be going in the opposite direction. Above it appears to be going in the forward direction. This is observable if you travel through train or some bus. So let's me play the clip. So you can see uh, the wall appears to be going backwards, but the mountains or the clouds appear to be going forward, but they are slow in comparison to the wall. Okay, so let's start with another cue, that is your optic flow. Well, as you move forward, the world rushes by you in the opposite direction. Things appear to get larger and bigger, even if they are appearing small far away. So as you move closer to it, things appear to enlarge. Well, so there's a road, and when I move forward, it appears the world is passing behind me from the thing I am focusing on. So that is optic flow. So this is a clip. So basically, suppose you are driving and the tree that is far away looks small, it enlarges. As you are moving forward, things appear to enlarge. So this is what happening, and the world appears to be going behind you, like the trees are going behind you, everything is going behind you as you move forward, and the world is becoming larger and larger, and you are getting more information. So in a sense, this is what Gibson came up with. So that's all. Okay, so optic flow can be in two forms, like translation, moving forward, or rotation. But in both the cases, from your focal point, the world appears to bypass you. Okay, ocular mode. Motor cue, basically the movement of the eye or lens or the eyeball. So accommodation. What is accommodation? Automatic change in your lens shape to focus on an object as the object changes its location. So suppose if I have a convex lens, it kind of shrinks to focus on the distant object, but it enlarges when I'm focusing on the nearby object, like reading a book. The other is vergence, basically the rotation of your eyeball uh, as the object changes location. Okay, so convergence. When the thing is near me, my eyeballs rotate to focus on it inward as it appears near to me. Okay, eyeballs rotate inwards to focus on the nearby objects. Cool. The next one is divergence. Well, basically, eyes rotate outwards to the normal location as to focus on the faraway objects. Well, pretty self evident. I'm pretty sure you have tried the first one, that is convergence, at some point in your life. So, yeah. So, binocular cue. Binocular disparity. Well, what is it? Well, when different images of the same object or the field appears on retina of each eye. Well, basically relative to the object, you have one eyeball and it covers a certain area. The other eyeball covers another area depending on the angle. So, if I close my eyes and look at the lamp, maybe from the right angle, the lamp appears in a different direction in comparison to the left one. So yeah, that's what is appearing. because the light rays and the area I'm covering are relative to all the cues. It's different, and my brain combines both of them. Cool. So in the next topic, we are going to cover about illusion. So yeah, that's all. I hope you enjoyed it and you understand the cues involved in the perception. And I'm gonna see you later. Thanks.